Okay, guys. Now we're going to solve threesome. Given an integer array nums, return all triplets ijk such that I is not j, I is not k, and j is not k. Yeah, and such that these three elements add up to 0. Note that the solution set must not contain duplicate triplets. So it's quite similar to twosome actually, but one of the most important things here that we do need to realize is that the array does need to be sorted first. So yeah, why don't we get into it? And enumerate nums. Okay, I just need an output array as well. Now, first things first, if the number is actually bigger than 0, we are just going to break out of this for loop. As we know, let's say it's all sorted right, and it's bigger than 0, and this is our left pointer. If it's bigger than 0, then like no matter how much we add, it's not gonna, we can't find any because we've already sorted the array, meaning this is going to be a it's going to be a ascending, array. Sounds good to me. Then we're going to have 2 pointers, left and right. Left and right is going to be, this one's going to be the length of numbers. Then simply we're just going to do a while loop. So we can actually add up the numbers here. Let's try it. Nums of I plus nums of L plus nums of right. If no, it's sort of a binary search actually. Sort of a binary search, sort of a 2-pointer search, but we can see it. So while L is still smaller than right and that is bigger than 0, this means our right is too big, right? So we're going to go down. Right, it's not really a if, it's going to be a if. It's smaller than 0. Then we're going to go add 1 to it here. If add is actually equal to 0, we can create a new temporary array with ILR. We can append this to our output array. Now, the important part is we cannot contain duplicate triplets. So let's say we have something like -1, -1, 0, 0, 1. Right. So in our first iteration, we're going to get an array of -1, 1, 0, and 1, which is all fine. But then if the I moves on to the next number, which is -1, we're going to see that it does the same thing again. Actually, no, we're going to add 1 here. So after we found this, and this, we need to move this to the left here. And then this down here. Let's see. Do we need to move that down as well? Pretty sure we do. Then we'll do 1 more here. And nums left is equal to nums L plus 1. Then we're simply just going to move L up by 1. Cool. So that looks good. I am missing something up here. If I is greater than 0, and then nums I is equal to nums I minus 1, we're going to continue. Oops. Let's see, runtime error. List index out of range. Yep, because we need to minus 1 from the length. So my answer is 125 because I'm not supposed to put in the indices, supposed to put in the actual numbers. Closing parentheses does not match opening parentheses. I need extra. There we go. Yeah, so let's try submit this code. And I got the wrong answer, which is completely fine. Let's see. More details? Does that show me anything? Okay. That's fine. Let's see what actually went wrong. Okay. So let's see. Oh, of course. I'm getting the wrong signs here. Yeah. I thought I fixed it, but literally, literally nothing got better. Let's see. Okay, so it works for this case, but it doesn't work for this case. Okay, let's think about this one. So it's going to be -1, -1, 1, 0. So it's -1. Okay. So let's think about it here. So it's -1, -1, 1, 0. So we're going to start with I equals -1, L equals -1, and R equals 1. So in the first iteration, it's going to go, okay, well, yeah, well, it's going to be indices, not the actual number, but that's fine. It's going to add those up. It's not true, so an add is, it's going to be smaller than 0. So it's going to go here. So it's going to add 1 to our left value. Oh, actually, I don't think we need those. Okay, I lied. We actually do need those. Well, let's see, yeah? So we add 1. Yeah, so it's more than 1, so we add 1, and then now this becomes 0. Now at this point, add is not 0 because we did it there. Now maybe we put it in here. Yeah, that makes more sense. Ah, okay, that was the answer. Very good.